For our last example in this section, we're going to do one more type of Saccheri quadrilateral, and we're going to do it in spherical geometry. So it's a little bit harder to draw this picture. And then we'll answer the question, what can be said about the summit angles of the particular Saccheri quadrilateral that we're going to draw? So the first thing we do is draw a sphere, which we can't really draw a three-dimensional sphere. So draw a circle, but it's going to look like a sphere when we're done with it here. So draw the equator from east to west, but don't draw it as a straight line. Kind of draw it like this. Okay, so that would be the equator. And if you didn't know this, the equator goes all the way around, and it's considered a great circle. And we're going to draw two distinct great circles, this time through the North Pole and the South Pole, like that. And so we're going to make them look like this. So we're going to basically make them symmetric of the vertical line connecting in with S. We're going to make them look like this. Something like that. Okay, so those are two great circles. We're not drawing it on the back. These are just facing us on the front of the sphere. All right, label the points where they intersect, right here and right here. Let's call that A and call that B. All right, so now we're going to label a point D on one great circle, one of these north-south great circles. So let's put it maybe right about here. And then we'll put C over here and make these arcs the same length. D to A, C to B. And if you're interested, this would form another great circle going through east and west if we went through those 2 points as well. So what do we have? We drew these to be equivalent, that length arc and that length arc. We know that these are right angles because it's going through the equator, east to west. And then what we have is this rectangle is our Saccheri rectangle, or Saccheri quadrilateral. And one thing we have here is that the question was asked, what can be said about the summit angles? This and this. These are actually greater than 90 degrees in this geometry. 90-degree base angles, summit angles greater than 90. So you could say that the interior angles add up to not 360, but a number greater than 360 degrees. Now, it is possible to draw this, not this one, but there is one, quadrilateral, Saccheri quadrilateral, where these would be right angles. And that would just be considered a rectangle. But by the way we drew this one, that's not the case. So just interesting that those angles are greater than 90 degrees each, this one and this one, the summits.